Okay, if I could get your guys' attention here real quick, I would appreciate it. I want to go through, and I'm filming this now so that my TOC, Mrs. Peters, can show it again tomorrow, but I want to make sure that you guys are real clear on what tomorrow's lab's going to be. This lab, I want you guys to write this lab up the same way you wrote up the gravity lab. So you'll have your own front page, you'll have your name, you'll have your partner's names, you'll have the object, you'll have your, which in this case I've called the purpose. And again, you can say C lab handout. There's some pre-lab questions that I want you to answer at the beginning. You've got your materials, and then you're going to go ahead and you're going to launch into a whole ton of data collection. The procedure for this lab is relatively straightforward. It's all walked through right here. If you read it closely, you'll be fine. The force of static friction is the amount of force shown on the spring scale at exactly the moment when the block starts to move. The force of kinetic friction is easier to measure. You guys are going to do both of these. I've got all of the equipment up at the front of the class, and I'll show you which pieces are for what real quick here before we go. You're going to set up a couple scenarios of the same kind of thing. You're going to have a friction block. There are two different friction blocks. And I'll bring them over here so that I can show them on the video. Hey, you're going to have questions tomorrow.
Is it by yourself?
Oh, absolutely with a partner. With a partner. So this is the first friction block you're going to use. And you're going to analyze whether or not the surface area of the block has any bearing on the coefficient of friction. It may not, because these on the sides of the block are not the same. You've got kind of a rougher, thinner side. You're going to have a thicker side. You're going to add masses to it. The masses are up at the front, and it tells you what kind of masses to add. So this is going to be the first block that you use when it asks you for a friction block with an eye hook. You've got a set of instructions that you're going to go through. I've got two scales set up for you guys to weigh things. The scales only go up to 600 grams, so you are likely going to have to weigh the pieces individually and then add their masses together to get the total mass, to get the total FG. So this is the first block you're going to use. It'll walk you through what I want you to do. It's this first table here. I want you to do 3 trials at each level, and you're going to average your results together. All of this is outlined how I want you to do it in here, but that's why your data table starts with 3 zeros, because you're going to do 3 trials at no mass added. And then you're going to do 3 more trials at another mass added. You're going to do 3 more trials at another mass added. And follow the instructions outlined in the procedure. Then you're going to do the same thing again after you've changed the surface area. Then you're going to do the same thing again. Can you stop moving? You're going to do the same thing again with this little block instead. I only have 8 of these, so you definitely cannot go alone. You're going to have to work in groups of 2 or 3. 4s are no good. I like 2s and 3s. This little block has 4 sides that you're going to use. It's got kind of a rougher side, a sandy paper side, that I've actually called sandpaper. It's got a blue side. I have labeled the blue side vinyl. It's got kind of a cardboard side that I've called particle board, for lack of a better word. And it's just got a flat wooden side. And what you're going to do on this page is you're going to pull those different surfaces 3 times each across your desk, wood, desk, vinyl, desk, sandpaper, desk, particle board. Then you're going to do metal. You're going to move to that metal sheet over on that dark brown table there. Then you're going to do the same thing on the plywood, which is the big table, the tall table over there next to board on where it says 8 and 9 on my whiteboard over there. That's the plywood station, and you're going to do that the same thing with each one of these. You're going to figure out how the force is pulled using the same kinds of scales I've been using. Mine look like this. Then it goes up to 50 newtons. You guys don't have that. You guys are going to use these scales instead, which whichever one best works for your applications. These scales go up to 5 newtons. These scales go up to 20 newtons. And everything you need should be up here. Read through the instructions. I've tried to write it out as clearly as I can. You will not likely get this thing done tomorrow. That's okay. I don't expect you to. But I do expect us to be able to get it done by the data collection, at least, done by the end of the class on Monday. Because that's when I'll do that. If you've got any questions while you're working, do your best to help each other out. If you're really desperate, fire me an email. I will be able to respond to emails. I'm going to a math pro meeting at U of B. So if you're really desperate, fire me an email. Otherwise, good luck tomorrow. And if you have forgotten what it looks like to formally write up these things, I can show you that on Monday and we can go through that again. But you should have it as part of your Gravity Lab handout from a month ago. When the bell goes, you may go as well. Good luck on this stuff. Crack. There it is. Have a great day. I will see you on Monday.